Okay, welcome back everybody. So we are going to continue on working on the Daedalus, and we have a few extra things to do today. So we have a few more cleaning up of wires and kind of containing everything so that it's a lot more presentable as a final printer. And one of the best ways to do that is to use one of these guys. This is called a cable raceway, but they think this is just a cable tray. And you can see these little things on the edge. This looks a little bit weird. This isn't a part of the design. This is something I had to print out because I noticed as you mounted the raceway up against the plastic panel, these little slots did not reach, and it was off by quite a bit, almost 18 or 19 millimeters. So I printed off these little items, these little spacer blocks, and then I put some epoxy and epoxied them on. And yeah, it actually came out pretty nice, pretty well. It's got the Voron logo, which is kind of fitting to the Voron stealth burner that we are using. So there's that. If you can see that there is a little bit of a white residue, and that's pretty common whenever you use any sort of bed release agent like glue stick, or in my case I use the nano polymer stuff from Vision Miner, and that stuff is great for ABS, but it leaves like a weird weird film on top of things. But on the bright side, it did allow us to print this stuff. And speaking about it, your next question is, what is this? So this is going to be the fan holder, and this is going to mount, if you can imagine, there's a 2020 rail right here. This is your imaginary 2020 rail. This is going to mount just like this, and we have these slots in here so that we can put a tool in there and actually reach our M5 bolts that we're going to use. So like I was saying, I have these old Noctua fans, and something to always look out for is, where is it? There should be an arrow. I think you guys can kind of see that, but there should be an arrow right there that shows you its direction that the air is pulling. So we'll have air coming from the outside of the case inside, just like that. And the way this works is that I installed some heat threaded inserts into my piece here, and then we're just going to put bolts in here. And what you can notice is that I drilled out these top bolts so that we could use panhead M3 bolts, and then we can just directly attach it to this. And this is going to sit properly against the frame and spaced out enough where it just goes right over the PSU. So that is a few of the things we're going to also do. Some of the other things that we're also going to look at is I really want to PID tune the hot end, PID tune the bed. I want to show the input shaper results, and at the very end we're going to see two things. We're going to see what our max movement speed is on this printer and this build, given that it's a 48 volt build, and we're going to try to get our first print in today. So this is a pretty exciting video in my eyes. I'm going to show you guys all the progress. Sit back, relax, get some snacks, and let's jump into it. Okay, welcome back. So here is the finished printer. You can see I did quite a bit of work to make sure all of the cables are really well addressed and really cleaned up compared to the original. Here I will show you the original. So I wanted to show you guys the original layout of the cables and the absolute rat nest of cables all over the place. So next up, I want to go through and just kind of point out some things that I had to do just to kind of clean this up. And I used these Voron labeled cable covers just because they were available, and they look really nice. It cleaned up everything, and you can see everything's really nice and available. So one thing, like I was telling you guys, that I wanted to do, make these Noctua cable covers. So here it is, fully installed, fully put together. It came out really well, honestly. And you can see up close I had some heat inserts in the certain corners, and then I used a couple panhead bolts just like that to attach it. So yeah, what I was planning on doing was taking it and attaching it right here over this edge, and then like this over this edge. But I ran into a problem. So here is the problem that I ran into. Let me see if you guys can tell what the problems are. So you can see that right here it is too long. It is actually just too long of an item to fit. Now, once I go back into the CAD, it will show that this is totally a thing that can fit. But what ended up happening was that the mounting plates, I didn't take into account the mounting plates that connect the PSU to the DIN rail have a set thickness, and that thickness is actually going to eat up a lot of the space needed to apply these fans. So what are the solutions? So yeah, as I was mentioning before, I needed to make some low profile PSU mounts, and this is my current solution. So yeah, the top item right there is the PSU mount, and it is much smaller as seen in the CAD, and what it allows you to do is it cuts down the height. So on top here is the original PSU DIN rail mount from Voron. That thing's about 17.5 millimeters, and the one I created, the low profile version, is 7.5 millimeters, which is amazing because it allows us to finally be able to fit my piece with roughly 2 millimeters of gap in the back. As you can see, there's a little bit of a gap right there, and that's perfect. That's exactly what I was looking for. In the process of figuring this out, I noticed that my my actual piece here, let me see. So yeah, I noticed that my actual piece here is not perfectly in alignment with the 2020 rail. It looks like I picked the wrong midline point to make my holes off of, and what this causes me to do, or what this causes, is there is now a gap that protrudes. The fan cover is a bit proud, and it might be able to clear with the foam tape that we're going to add in the next episode, but I don't want to risk it, and I don't like it. So what we are going to do is we are going to reprint this part. I also noticed that it was a bit difficult to get a 3mm wrench in here, so I'm going to add some provisions in the next model to allow me to put in a 3mm wrench and comfortably tighten it up, or at least use a ball head socket screw and comfortably tighten it up. One of the best things about this part though, and I'm glad that I implemented, was that you are now able to use the elbow of this hex key and fit it through, and then do all your tightening that way. It is a little bit cumbersome since you maybe have, I don't know, 30 degrees, maybe like 30-40 degrees that you can actually wrench on, which isn't too bad. But if I can get it all the way in and tighten it this way, that would be even better. So we are going to reprint, we are going to redesign and reprint these and get this back on, and I'll see you then. Okay, so the fans have been upgraded and they finally have the mounting points changed, and as you can see, some pretty big differences. We opened up this area, and I decided to chamfer all of this in just so that you can have really easy access to these bolts right here. I still recommend that you use a ball head screw like this to insert these bolts, just because they're a little bit tricky to get into. But besides that, they're really good. And as you can also see, everything fits, everything is nice and flush to the back edge. As you can see, just like that, flush to the back edge. Everything works really well, and it is going really good. So what I did is I routed the cable for this fan. I had the fan cable pointing downwards, routed it under here, moved it from here, and then crimped both fans and put them right here onto the board, and did the same thing for the second fan, moved it right here. Something to notice is that these are 12-volt PC fans, so make sure that the little marker is actually put on the 12-volt side right here and here, and not on the 24-volt, and 5-volt is okay, but 24-volt very bad. These fans will die instantly. So yeah, those are the fans. They seem to be working really well, and yeah. Okay, so something I also been meaning to do is, it's been a couple episodes now, and there might be some new individuals to the channel or to the project, and they don't know really what we're doing or what the specific upgrades are. So I wanted to run through the upgrades kind of quickly and show all of the upgrades that we have done. I feel like I've said upgrades about 10 times. Starting off, we have redone the tool head on the other side. So starting off, we have the upgraded tool head, which is going to be a Voron stealth burner tool head, and I decided to install the Rapido 2 tool head into it, and we're going to use the Clockwork 2 extruder system just because it's all really well documented and really easy to assemble and to tune later on. So very happy about that. I got the SB2209 board on there via CAN bus, and yeah, there is that section of the tool head. I got the LEDs working now. I don't know if you noticed, but previously the two bottom LEDs were not working, and I had to swap them out for a different set of LEDs. And so those are working now and working really well. So on to the other parts of the electronics. So the first big upgrade that we did was, I don't know if you guys heard that, but was with the motors. So a couple of things we did was that underneath the motors, right here, if you can see, we decided to put dampeners onto the motors. This was for a couple reasons. This was mainly due to the fact that these motors would sound really, really loud when they were operating on the original Daedalus, and it drove me nuts, and it was just like vibrating throughout the frame, and I just didn't like it. I don't know if it ever affected print quality because the original Daedalus kind of worked a bit slowly, so it's not like all that crazy, but I really didn't like it. So we wanted to make sure that we can get some decoupling of the motor vibrations and make the whole system quieter. The next thing is going to be, what is this? This is a double shear bearing mount for the top of the motors. Let's see if I can get that in focus. But pretty much right here, right on that edge, and there's another one here. We've got bearings that are going to hold the motors perfectly in space so that it won't shear off due to belt tension. And what this allows us to do is to run higher belt tensions, get better input shaper graphs, and just run the system faster and harder, which is great. Moving on, the next section is going to be the board. So originally this printer came with a duet board. I think duets are really great, but it was a little bit overkill, which I understand is the whole point of Railcore. But the other thing is that I just don't like dealing with duet. It's a personal thing, nothing to do with them. It's just I don't like dealing with the duet system. I'm much more comfortable with the big tree tech system. This is like a personal preference again. What we have here is the Octopus Pro, the H723 version, which I think is the fastest version that they have currently. And we are currently using two 5160 step sticks and then three 2209 step sticks. And I have this fan here not for looks, but truthfully because the 5160s at the voltage that we're running, which we'll get to later, will overheat if you don't cool them. They need constant and active cooling. So what I did is I put on this 5160 fan and put it onto the active cooling port right here. This is really nice on the board because this means that you don't need to turn anything on. As soon as it gets power from the PSU, it'll instantly have this fan running at 100%. I might change this to be at 70% because it is a lot of air and it should be enough to cool it down, but I don't want to during a long print for this thing to just cut out on one of the motors. And I don't know if I already explained it, but that's what's going to happen. If this ever gets warm, one or both of the motors will just turn off. I'm assuming it's going to be this one that turns off. Well, it doesn't really matter. Each one of them will turn off, and then you'll get like the tool head. It'll just move in diagonals. It'll never move in a straight line, so you can never home it, which is really annoying. Moving on to the brains of the operation, we have the Raspberry Pi 3B Plus. I chose this because I just had it laying around, so it's really good. You can see there's a couple extra cables here, and we'll get to that later. But one thing you'll also notice is that I did flip this thing around from what it was in the original version. The reason for that is that we needed to add a screen, and the screen was giving me problems, so I decided to use a different screen, and that screen required this HDMI port, and this cable was just too long to fit under here. So there's that. People recommended that I get the Raspberry Pi its own dedicated power supply. So I have a 5 volt, 25 watt power supply feeding just into the Raspberry Pi, just so that it always has constant power and no issues there. We've got a standard Omron, I think it's a 10 amp SSR, so it's working perfectly good. And onto the brains of the show, we've got a 200 watt 24 volt PSU here that's going to be powering all of the board and just the board and the Z motors here. And then we've got the 48 volt 200 watt power supply powering just these 2 step sticks. Something I didn't mention on the motors here is that we upgraded the motors from the stock motors to 2504 motors, LDO 2504s. These are really, really good motors, and they're running at currently 1.9 amps each. So yeah, and the other thing is I really wanted the power supplies here to have some sort of cooling as we're running them. One of the coils I measured, I don't know if you guys can see it, but one of the coils inside I measured at almost 100 degrees, which I understand this thing could be able to easily handle, but didn't feel comfortable with that, and I didn't really like that. So I decided to use these old Noctua A14 144 or 140 millimeter fans, and yeah, instead of tossing them or trying to sell them, I decided this would be a great place to use them. So yeah, there is that, and that is pretty much the whole system in a nutshell. So one of the things that I really want to upgrade is I really don't like the DIN rail clips that look at that, like, do you see how much movement there is there? And similarly to this RPI, there's a lot of movement there. So what I'm going to do, similar to the DIN rail clips that I put on here, I want to modify them specifically for the RPI and the power supply, just so that there's a nice tight fit against the DIN rail, because you know this is sliding down and I don't want any chance of some short circuiting or whatever to happen. I want it to stay in its place as it's working. Another thing that I had to modify would be this top bar. As you can see, originally there were blind joints on the sides here and here. Let me show you. Yeah, you know, blind joints right here and here, and that worked well, but as I was leveling linear rails to make sure that they were equal on all 4 sides, I took a measurement and I used an abstract number of 99.5 as the set distance. And one thing I did not realize was that you can't really see it, but 99.5 meant that the 2 bolts here were just shy of the hole. So you'd have to, like, you know, bend a piece of you couldn't really ever get a tool inside of there to actually get it to work. So that was really annoying. But we came up with a nice solution. Instead of remeasuring all the corners and then redoing all of that, which is way more work, use these corner brackets here and here to keep this bar up and stable, and in my opinion, easier to move around. So there is that. So yeah, concluding all of that, the next question probably is, what's next? What are we gonna do next for this guy? So the next thing that we need to do is we need to PID tune the bed. We need to PID tune the hot end as well. We need to add a couple add-ons to this whole thing, including CAMP, which is going to be the probing system that doesn't make us probe everywhere. When we need it, we can just probe wherever we need to for the print. And then we also need to add exclude objects. So after we do that, after we get it all PID tuned, I really want to hop in and start printing and get our own little first print going. Also, the other thing that I forgot to mention is you know, what are these cables here? So one other thing is I decided to add a little camera right there. I don't know where to put it exactly. You know, I know that I needed to add a camera, and I just put it there for the time being. So we have a camera. And then the other thing is I've been testing out a display. I've been really wanting to use the original panel do display, but it was giving me some problems. So I opted for the Big Tree Tech 5-inch display. So I had to make a custom housing and make sure that it all worked, and it looks like it does. So this is really happy and really good. One other thing I forgot to mention is that this is the original filament sensor. So we are going to be using this original filament sensor as well. And yeah, I got that thing wired up. It's in there and it's connected right up there, if you can see that. So yeah, you know, purple, red and blue, red and blue. So it's connected, it's in there. And yeah, this is the Sentinel, I think, from Dye's design. So yeah. And yeah, that's about all for all the upgrades. So yeah, let's hop into the browser, into the CFG, and get the PID going, and update the camp configurations and exclude objects. And hopefully I can show you guys all of that and get a print started. Well, sigh, as I was trying to update my main component files on the Daedalus printer, I suppose there must have been a bad update somewhere, either with Moonraker or with Clipper or whatever other important files there might have been. Long story short, I could not get the printer to communicate with Moonraker, causing the printer just to not be even accessible, which was really frustrating. As you can see here, I had a ton of files here, installing, you know, deleting, removing, and then reinstalling, even Clipper or Moonraker. Nothing seemed to help. So I had to wipe the SD card now, and I'm having to reinstall and reinstall Clipper, reinstall the can, and do all of that crap. Yeah, I guess it's good to show you guys the good side and the bad sides as well. Like, nothing, especially with 3D printers, can go super smoothly, but this is just kind of like a nonsense thing. It was just a bad update, and I guess certain files weren't in the right position, I suppose. But anyways, we will get this fixed, up and running, and we'll hopefully get this back to where it is. I probably do need to recreate my whole printer.cfg file, which I'm not happy about, but yeah, let's do this quickly. Wow, okay, lucky enough for me, I actually was able to go through one of my old videos and find that my printer.cfg files were actually saved. So I was just able to go through the video, and here's the video I'm showing from, I think, the last episode. And yeah, I just went through each one frame by frame and added it line by line, so I didn't have to do too much. Thankfully, this whole thing wasn't too bad. All you had to do is just reflash the RPI, and that wasn't all that hard. And then you had to just do the very first steps on the esoterical guide, which is just setting up CAN ports, making sure everything is at the right bit rate, and then everything worked out perfectly. So I think I got off very lucky here. Thankfully, I had the recording to just save me, but yeah, it all worked out. Welcome back, everybody. So we got the Daedalus finally all up to speed. So we've got the camera working, we've got the RPI working, I've got my printer.cfg working, and like I was saying, I got really lucky with that recording, having all of the information I needed. And luckily, even through the recording, I recorded the whole CFG, so I got super lucky there. And yeah, here we are, we finally have it up and running. I wanted to show you guys another home, and then I will PID tune the extruder with you all, and then I'll PID tune the bed as well, and we should be able to run the input shaper. Afterwards, we will also do our first print. So yeah, let's do that, and I'll show you the process of doing a PID tune. So first off, you're gonna just start with a home, and we have the camera up here, very handy. We can see it doing its little home. I had to turn off the LEDs because the LEDs are blinding to this camera. Let me give you a look. Yeah, so there's the LEDs. It's pretty much it's pretty blinding, but we'll put it at 50 just so that it's on, and then we'll do the Z tilt adjust. Wonder if you guys can hear that on my microphone, but you can hear it in the background, making a good little bit of noise. And it's doing its measurements, and I have the tolerance set pretty tight, and it should be able to hit that. On its first try, it was hitting what it was. It's old, close to its old tolerance, so we're good there. Boom, there we go. There's that. So we did our first home, and we are gonna do PID testing with the extruder now. Okay, so we just finished the extruder PID tune. So I never really explained why you're gonna be using
the temperature of 220. Also, this just finished, so yeah, we just got that done. Next up, we're gonna have to do a save config, but I picked 220 because we're gonna be printing with PLA today, and the majority of the things on this printer will be probably PLA or PETG. So we wanted to target that, and then for the bed, we're gonna do a PID tune of a 60. So it's just like the normal temperatures you're going to be running. If you're going to be running like ABS or ASA, definitely PID tune to that value that you're going to be using. I know 220 might seem a little bit hot, but this printer can go pretty fast, so it all kind of makes sense. Okay, PID tuning has just been finished. So I think next up is doing the input shaper. We're going to be just doing, I think, just a shaper calibrate, and I believe this should work. Let's try it out. Maybe I might need to home, but okay, so the input shaper results are now in, and before I do that, so I just ran the shaper calibrate command, and what you'll get is you will get two CSV files with the current date and an identifying code, and this identifying code and date will be the same for both X and Y. So what you'll do is you can take this little piece of code right here, and if you just copy in the date and this identifying code and you type it into your choice of SSH service, I like to use MOBA Xterm because it pretty much combines WinSCP and PuTTY together in a much prettier environment, meaning that you can type stuff in here just like in PuTTY, and then you actually get the real directory of files, so you can actually open and close files and download them to your computer, which is really, really nice. But anyways, yeah, you just copy and paste the codes. It'll run a couple of the data points, and then it'll output those files into the temporary folder. To get to the temporary folder, you could go back, then go to TMP, and you will have your two files right here, and we can take a look. It looks like X is at 11,200 with a sharp peak, and yeah, man, this is looking really good for X. That makes about sense for a machine this sized. And then let's look at the Y. This is the real thing that really matters. And yeah, this looks about right for the Y. It is at about 7,000 MZV. It looks like there's a secondary peak. So I'm imagining something is wobbling, or it could be the drag chain causing some issues there. I'm going to probably chalk this up to the drag chain causing some issues, but still having this as the lowest value on your printer is still quite zippy and quite fast. So we will hit save config, and we will now start our first print on this little guy, and let's get that going. All right, as you can hear behind me, you can hear the fans recording and going crazy, but we've got finally all of the items ready for this printer to start printing its first item. So what we're going to be doing is we're going to be printing on just the Voron cube and the Humble Benchy, and we're just going to make this kind of go conservatively. I just loaded up a 300 by 300 Trident, and I used just the generic Voron qualities and strength and all of that. I didn't include the fast speeds. I didn't do any of that. I got all of the items for camp all set up and running. That took a little bit of tests and trials and adding a couple of configurations here and there, but finally have that done, and we should be ready just to start. I did also set the Z offset to be like 0.5 millimeter just because I know it's going to be pretty high, so I don't want it to crash and burn into my bed. But yeah, let's start that, and then once this thing actually starts, I'll show you guys how it all goes.
Believe it or not, here's our little guy working. Look at him take down those layers. I had to cancel the boat because it was just not wanting to print. I don't know if you can see it, but my first layer for the Benchy was way off, so I had to lower it on the fly, and I got it just in time for the Voron cube to finally print. So we will see how that is, and then we can scrutinize that after the fact, but it's coming along really, really well, so I cannot complain. We'll see how it is in just a little bit. All right. I also wanted to show you guys the back as it's running. We got the two Noctua fans going pretty good on the PSUs, and then we've got this fan I set to 50% because it was just a little too loud and annoying. And what's crazy about this setup is that the amount of air that these guys are pulling is helping cool down these two motors, if you can see that, these two motors up here by an enormous amount. I mean, you can feel the air coming off the top and the side, and it shouldn't be able to hit up here because it's pretty, you know, it's going to be baffled by the time it gets up there, but it'll help cool down the motors and hopefully the rest of the system. If I see any problems with the stepper motors getting too hot, I will just turn up this fan to either 100 or 75%. But yeah, here we go. Okay, everybody, I have the finished parts from the Daedalus, and yeah, that was quite fun trying to get the Z offset in the right place. That thing was like that far off the bed, and I had to like rapidly touch the baby steps to make sure that it actually finally touched. In the first part, I had to throw away the first benchy, and then I got to keep this guy. This is pretty good. Let's look at that top surface. I think you can see that. That is a pretty flat, well-tuned top surface. And let's look for some ringing. I truthfully can't see any ringing from the actual parts that I want to see. Let's look at how sharp the corners are. Corners are pretty sharp, dude. The overhangs are looking pretty good in this section. I don't have a bearing that you can fit in here, but that is a thing you could do. But yeah, this is looking, oh yeah, let's look at the first layer. First layer is looking good. You can't even tell. At the top here, you can tell a little bit. Maybe that'll pick up, but yeah, it's looking really, really good. But as you can tell, there is a bit of a repeating pattern on the skin here and here. Oh yeah, you can really tell it here in the X direction. But most likely what this is that it's a bearing or some sort of motion because of how fine these ripples are. Or it could be a bad belt, but we're gonna see. Here is the benchy. It came out pretty stringy. I was using some ultra crappy PLA that I just had laying around. But yeah, let's look at the top surface. Top surface is looking really good. The benchy actually looks like a benchy, right? Like that's pretty impressive for no real calibration outside of just, you know, using what the normal Voron spec was in Orca Slicer. Let's look at that. This looks a lot better. There is a little bit of undercooling right here, and I think that's due to just the speed and maybe the print being a little too warm for what we needed. But I mean, honestly, this is looking pretty good. I mean, I can't really be too mad at it, so I'm actually pretty happy with this. If I had to investigate why this was the case, I would guess that I might have not properly adjusted the heights of the actual idlers on the corners, the front corners of the Daedalus. And I want to reduce the height. I mean, we can just look at the belt path. The belt path, if it's in the correct place, we should be able to just reduce and mess with those heights. That was something that I completely forgot about when I was adjusting the height of the actual linear rails. Like, you need to adjust those as well. So we'll have to adjust those and see what it comes out to. All right, so to get these max speed settings, you will need to go into your printer.cfg and update your max speed to be like something like 100,000, right? Something you probably won't be able to hit. And that allows you to hit these max values and see what happens, you know? I don't think I'll ever be able to print or even like, yeah, print faster than 450 due to the cooling on this machine, but I should be able to accelerate up to 40,000. So we're gonna give this a try and we'll see what happens. All right, let's hit enter. Oh, wish you guys could feel it. The acceleration is making the whole table shake. Oh my lord. Shaking like crazy. My whole table shaking. So it was at 56,741. Let's see if that was changed by more than 32 steps. Ooh, okay, so 56,741 to 56,747. We are in the clear. Let's bump this up to 60,000. Hope you guys can see that. 60,000. Looks like it's doing it. I'll put my mic closer so you guys can hear how loud it is. Looks like it did it. I ask you to forgive my overexposed screen, but the number to beat right now is 56,744, or to stake to, not to beat. And it looked like it got 56,748. We are totally good. Let's see if we can amp this up a little bit. All right, we're gonna bump it up. Dude, let's go 90,000, all right? After this, I kind of doubt I'm going to go anymore because that's pretty insane. For 48 volts, 5160s, just the normal step sticks. These aren't even the external guys. Let's see. Wow. Huh. And we got 56,748, meaning that we could, if we wanted to, push this further. Let's see if we can just hit 100,000 for acceleration. I have to keep the speed below 450, but I bet you could get this to be, yeah, perfect. Let's try this out. Oh my god. A 100,000 acceleration. A two-wheel drive motor is absolutely crushing it. So it went to 56,741. That is the number to be as close as possible to. And we got 56,751, meaning that it only lost 10 steps throughout that whole operation. The Y was even better. It only lost about, what is that, 4 steps, meaning you could push this to be something way higher. So this rail core printer has the easy potential to hit probably 800 millimeters a second, probably at 50 or 60,000 acceleration. if you have the correct cooling. So you probably need to add a CPAP for something like this. This is an amazingly well-built, strong machine. This is why I've always liked the rail cores. These were overbuilt, super strong machines. Just at the time, we did not have the just kind of R&D and know-how to deal with, the frame being way stronger than the components were. Now we understand that to hit those high speeds, you're going to probably need like an extremely high flow rate nozzle or hot end, something like the Goliath, something like the Mosquito Magnum Plus, something enormous. And then you're going to equally need some huge amounts of cooling, definitely 2 auxiliary fans, and definitely a CPAP to help really cool down all of those crazy speeds, and finding some really high flow, ABS or PETG. But that is all, everybody. Thank you so much for watching. In the next episode, we're going to try to get the enclosure done. We're going to add a top hinge and a few other bits and bobs. But hopefully you guys liked my little experience, dealing with the rail cores and making sure that this thing is more up to date in the year 2024. So yeah, hopefully you guys have been liking this. And yeah, sorry for not posting last weekend. I had to deal with some life stuff and had to deal with this stupid MCU or the RPI not working. But thank you guys so much. All right, I'll see you guys in the next episode. Take care.